Now we'll be discussing paper 2, which consists of 3 questions which are of NMO level, and we will start with question number 1. Now he says a whole number decreases 9 times when one of its digits is deleted, and the resultant, as in after deleting the digit, the resultant number, he's talking about that, is divisible by 9. And he says find all such numbers. Right? Now, first of all, he says whole number decreases 9 times when one of its digits. Now, which digit I do not know. Right? I don't know whether the number has one digit only 3 digit or 4 digit or 5 digit or whatever the case may be. Or maybe it has 10,000 digits. I don't know that. He says when one of the digits. Right? So, maybe we can talk about when the first digit is deleted. We need to talk about when the second digit is deleted. We need to talk about when the third digit is deleted, and so on. Right? There are numerous cases. Now, that seems scary. It's fine. It's okay. But let us just start the question. Right? Now, if I need to start the question, so I'll start with the most primary case that I can think of, which is when I delete the number which is at the beginning. Right? So that means if I have a number like this, it has first digit, second digit, third digit, and so on. Right? I will start when I'm deleting the first digit. Right? Because I need to talk about different cases. So let me start with this one. Right? Okay. Suppose my first digit is A. Right? My second digit, I don't know. Third digit, I do not know. Fourth, I do not know. Right? In fact, I do not know how many digits are there altogether. Right? Okay. So, but I need to write something. But then I cannot do B, C, D, E, F, and so on because I don't know how many digits are there, right? So what I'll do is, if the I don't know anything about the remaining number, so let me consider the remaining number to be X. The entire number to be X, right? So I suppose because I need to delete this one, right? And I suppose my first digit because I need to delete, and the remaining digit to be X, right? Okay. Now, if I need to write the number, now first of all, I don't know how many digits are there, so I will say maybe they are like this. I have 1,000, so we say 1,000 into 10 raised to the power 3, right? So maybe they are k digits over here, or n digits usually we take, right? So my number will, in expanded form, will look something like this: a into 10 raised by n plus x. Right? My number looks like this and the expanded form looks like this. Right? Now he says the number decreases 9 times when one of its digits is deleted. Now if I delete this number, what number is left? That is just the number x. Right? So this is x is my resultant digit. Now he says the whole number decreases 9 times. So that means decrease is 9 times. So original number, resultant number. If I divide the two, my answer should be 9. Right? Okay. So let's start then. Cross multiply करते हैं. So a into 10 raised by n plus x equal to 9x. Right? And from here I get a into 10 raised by n is equal to 8x. Right? Okay. We have arrived at this equation. And from here I need to find the value of a. I need to find the value of n. I need to find the value of x. 3 variables are there, and just one equation is there. Now, let us see. What else is given? The resultant number. Resultant number as in the number x is divisible by 9. Okay, so that means here 9 factor should come up, right? Also, by looking at this equation, this by this is equal to 9. Now, I know that this number is divisible by 9, right? अब ये number भी तो divisible by 9 होगा, तभी तो cancel out होगा यहाँ पे 9 आएगा, right? So, I can clearly see the initial number is also divisible by 9. Right, the initial number. Now, if the initial number is divisible by 9 and the resultant number, अब ये divisible by 9 है, that means यहाँ पे sum of digits because divisibility test of 9. Now, here the sum of digits should be divisible by 9. Here also the sum of digits should be divisible by 9. So, अगर मैं delete कर रही हूँ, ये number खुद 9 से divisible होना चाहिए. Common sense, right? अब 9 से divisible digit होते कौन से? 0 and 9. अब 0 तो यहाँ आ नहीं सकता, first place है. That means this number has to be 9. So here you were getting scared because too many variables are getting involved, but I have realized that a cannot be anything but 9. Reduce the number of variables, right? Now let's see. n को 1 पुट करेंगे तो 8 से डिवाइड नहीं होगा, n को 2 पुट करेंगे तो 900 by 8 वो भी डिवाइड नहीं होगा, इनफैक्ट 3 पुट करेंगे उसके आगे मेरे पास वैल्यूज आनी शुरू हो जाएंगी, राइट? वैल्यूज कैसे आएंगी? x will be equal to यहाँ पे आ जाएगा 125, 9 into 125 would be करने हम 5 4 2 2 11 1125, right? Next would be 11250 because I know n is a natural number, मैं पुट करते जाऊँ corresponding x की वैल्यू आती जाएगी and so on, right? तो एक बार इस फर्स्ट नंबर को चेक करूँ एक बार, right? मेरे पास x आया था 1125 but my the number is a is 9, my number is 9, then x is 1125, right? And my x is 1125. This should have been equal to 9. But is it? Multiply karo. This into 9 is definitely not this number. Right? This does not satisfy the condition. Next check kare. Okay, अब आया 9, then 11250. Divide करते हैं इससे 11250 के साथ. Right? Do you think ये divide होगा? अब वो तो 0 तो वैसे भी cancel हो रहा है. Right? So obviously this is not equal to 9. And all the numbers in this sequence will actually not satisfy the condition. When you try to delete the first digit, you did not encounter any numbers. That's fine. At least we have separated out the case. Right? Now, if the first digit has not been deleted, that means we should move on to the second one. Right? So let's move on to the second one now. Right. Now, I need to have first digit, second digit, third digit and so on. The thing is, since I need to delete the second digit, that means मुझे अब second digit को मैं x के में नहीं डाल सकती, right? मुझे separate out करके ही रखना पड़ेगा. So first digit, let me take it as a. Then second is b, and the remaining number that you can consider as x. Cool. And again, consider that these are n digits here, so that you can write it in the expanded form. Right, so expanded form a into 10 raised by n plus b into 10 raised by n minus 1 plus x. But before we actually do that, in the previous question we realized the values of a can either be 0 and 9. 0 we rejected and 9 हमारे पास आया नहीं. Now here a, let's talk about b now, the second digit, right? Now this is the original number. I know that original number is definitely divisible by 9. And the resultant number also has to be divisible by 9. So that means this deleted digit should be a multiple of 9 itself. तभी तो मैं sum of digits को divisible by 9 करूँगी, right? Now b is a digit which is a multiple of 9. There are just two possibilities. Either it will be 0 or it will be 9. Right? So that solves something. So first case में ले लेते हैं when b is 0. तो यहाँ पे अगर मैं b 0 लिया, this thing disappears. And this turns out to be plus x. I've reduced my variable, so that is a good thing, right? And second, अब मुझे दिखता है ये टर्म डिलीट कर दिया मैंने, right? अब पहले यहाँ पे n digits थी, अब एक digit किया तो I am left with n minus 1. So in expanded form, I have a into 10 raised by n minus 1. Plus, obviously, the remaining one is x. This obviously number decreases by 9 times. This ratio turns out to be 9. Cross multiply. So a into 10 raised by n plus x equal to 9 into a into 10 raised by n minus 1 plus 9. Right? You shift it to this side, that side. So यहाँ पे आया 8x equal to a into 10 raised by n minus 1. Cool. Right? अब निकाल लेते हैं. अब a के बारे में मुझे नहीं कुछ पता, right? Because I don't know it's the first digit. It can be 1. Obviously, it cannot be 0. It can be 1, 2, 3, and so on. So in each case, let me try to find out. So in first case, when a is equal to 1, this actually becomes 10 raised by n minus 1 is equal to 8x. From here, you'll put the appropriate values of n and you'll get the corresponding values of x, and x will turn out to be 125, then 1250, 12500. Right? My number, I need to write the number also. So my number would be 1. Second digit is 0 because I'm considering that case 10, 125, 10, 1250, 101250 and so on, because I'm increasing the number of zeros at the end, right? So let me check whether this satisfies the condition or not. So 10125, I will divide it by second digit delete करना है 1125, right? This should be equal to 9. Check करें. Actually it turns out to be 9. अब ये वाला हो रहा है तो next वाला भी होगा, next वाला भी होगा, and so on. That means you found one number or how many? You found infinite numbers, but you found one category of such numbers, right? Because इसमें आगे zero ही add होता जा रहा है. So one category is this one, even though there are infinite numbers in this category. Cool? Right. So one category we found out when a is equal to 1. Now let me put a is equal to 2. Now a is equal to 2, so this is 2 into 10 raised by n minus 1 is equal to 8x. So 2 factor cancels, so I am left with 4x. From here, giving the appropriate values to n, you will find that x will either be equal to 25, then 250, then 2500, and so on. And my number would be 2025, 20250, 20250, and so on. Right? You will check the condition. You will divide 2025. You will divide second number related 225. This actually turns out to be 9. So yes, you found another category of such numbers. Right? Okay. Next, a is equal to 3. A is equal to 3. That means 3 into 10 raised by n minus 1 equal to 8x. From here you find the corresponding values, because मुझे पता 8 से divide करने के बाद 125 ही आएगा. So 3 into 125, that is 375. Right, then 3750, then 37500, and so on. Right, so my number is actually 30375, 30350, and so on. Right, third category of the number. Then you can put a is equal to 4. So 4 into 10 raised by n minus 1 equal to 8x. From here, ये 2 cancel, यहाँ पे 2x आ जाएगा in fact. So यहाँ पे आया 5 से start हो जाएगा in fact. X equal to 5, then 50, then 500, and so on. My number would be 405. 4000, 10, and then exponential zeros, and so on. Right? In this way, you can proceed. A is equal to 5 आ गया. Now I am shifting it here. A is equal to 4 is done. A is equal to 5. You will get 5 into 10 raised by n minus 1 is equal to 8x. You will find that x is actually equal to 6225, then 6250, and so on. My number would actually be 50625, 50625, and so on. Then a is equal to 6 there. You will get 3 into 10 raised by n minus 1 equal to 4x. X will turn out to be 75, 750, blah blah blah. My number would turn out to be 6075, 60750, and so on. Then a is equal to 7. I am telling you directly. The numbers are 70875, 70850, and so on. Right? Now we come to a is equal to 8. Right? What happens here? When I am putting a is equal to 8, because I erased my equation was this. So 8 into 10 raised by n minus 1 equal to 8x. This and this gets cancelled. So x की possible values. In fact, x की possible values 1 से start हो जाएंगे. So 1, 10, and so on. 1 वाला तो होगा नहीं, but चलो, we'll see. So my number looks like 801, then 8010, and so on. But I realize when I am dividing 801 by 81, the answer is not 1. The answer is not 9. When I divide 8010 by 810, the answer is not 9. In fact, when a is equal to 8, I will not find any numbers. Then you will check for a is equal to 9. Right? Then also you will find out that you are unable to find the numbers. Right? So I have exhausted all the cases when the second digit is 0 and first digit I have taken to be 1, 2, 3, 4, 5, 6, 7, 8 and 9, the numbers does not exist. Right? So these are the 7 categories of number we got. Now, there's another case that we need to consider. Right? So let's move on to that. Right. Now, on the second place, I am forcing my number 9. Right? So my expanded form would be a into 10 raised power यहाँ तक लिया है n plus 9 into 10 raised power n minus 1 plus x. This is my original number. Right? When I delete this, I'll get a into 10 raised by n minus 1 plus x. This is equal to 9. Cross multiply. So I'll get 10 raised by n minus 1 and a is multiplied by that. Then plus 9 into 10 raised by n minus 1 equal to 8x. From here, obviously, I'll get a plus 9 into 10 raised by n minus 1 equal to 8x. Right? Now you'll be like, ma'am, cases bana lete hain, you can do that. When you put a is equal to 1, you will get 10 raised by n is equal to 8x. So that means x will turn out to be 125, 1250, blah, blah, blah. Right? Now, I will write my number because I need to check whether it satisfies or not. So 1, 9, 1, 2, 5. Second digit is 9, careful. Now delete kar so I will get 1, 1, 2, 5. When I divide these two, the answer is not 9. That means these kind of numbers do not satisfy my condition. Now you'll be like, ma'am, put a is equal to 2. You'll realize when you write the numbers, do not satisfy the condition. In fact, there's a very particular reason for that, if you can figure it out. Why? Because whatever my number may be, so A, 9, आगे जो भी digits हो, उसको हम C, D, whatever कर देते हैं, right? Divided by, if I say A, C, D and so on, right? If C is less than this 9th digit, right? अगर वो 8 आ रहा है, right? तो A8 और यहाँ पे A9, अगर मैं multiply कर रही हूँ तो 10 से greater हो रहा है. Can you see that? Right? अगर मैं 7 डालूंगी, again यहाँ पे A7 है और यहाँ पे A9 है, मैं 10 से multiply करूँगी because A7 सबसे into 10 करेंगे, A7 into something होगा, right? So that means अब यहाँ पे वो 9 वाला केस है. 9 वाला केस तुम देख लो. That would not be there, right? So you will realize कि second digit पे 9 है, वहाँ से केस मिलना ही नहीं था. You would have checked, right? करने के बाद में भी you must have realized कि क्यों check कर रहे हैं? You know, there must be some reason for that. This is the reason, right? So that means when second digit is 9, I am unable to find the number, right? Now we have considered the case when the first digit has been deleted and the second digit has been deleted. Now let's move on to the third one. What if the third digit has been deleted? Let's see. So my number of third digit चाहिए, so मैं से A, B, C and remaining को मैं डालूंगी X. Right? Okay. Let me write the number in expanded form. So A into 10 raised by n plus B into 10 raised by n minus 1 plus C into 10 raised by n minus 2 plus X. Right? But ठीक करने से पहले, you know, let's just think about it. ये जो logic तुम्हारा यहाँ पे जो तुम लगा रहे थे, don't you think वो 3 digit में भी लग जाता है? Let's just try to analyze it. Suppose there is a number 19872. Obviously वो condition को satisfy कर रहा है या नहीं कर रहा, हमसे भी analyze कर रहा है. अगर मैं यहाँ से second digit, third digit delete करूँ, मेरे पास ये होगा 1972. Right? अब मुझे देख रहा है when I'm dividing, यहाँ पे 197, यहाँ पे 198, ये into 10 से बड़ा ही हो रहा है, right? Right? मुझे तो into 9 चाहिए because technically ratio 9 होनी चाहिए. यहाँ पे तो into 10 आ रहा है, right? अगर यहाँ पे number 9 से smaller ही है, तो anyways number नहीं मिलने वाला मुझे because वो into 10 होता है. Now you'll be like, what if there is 9? Let's just try to analyze that. यहाँ पे 9 क्या है? यहाँ पे 9 क्या है? Right? अगर 9 में कर भी दूँ, I can say that this number is closer to 10. Into 10, I know exactly तो जाएगा नहीं, right? But ये 10 वाले multiple के ज़्यादा पास है. अगर वो 10 वाले multiple के ज़्यादा पास है, तो वो 9 वाला multiple कैसे हो सकता है? Right? दे दिया. Now just think about it. अगर 4 digits है, 4 digit को मैं delete कर रही हूँ, same thing. 5th को कर रही हूँ, same thing. 6th को कर रही हूँ, same thing. You think I should be checking numbers further on? Absolutely not. Because I want the decrease or the ratio to be 9, right? आगे वाले numbers जो भी होंगे multiple of 10 से आगे होंगे या multiple 10 से थोड़े से कम होंगे, right? 9 से तो definitely ज़्यादा. So that means the only case where numbers exist is that when the second digit is 0 and we have established those are 7 categories of number. right? And that is your final answer. Alright, we are moving on to the next question. Now, there are two parts of the questions. I'm doing the first part because I clearly need the board for that, right? So, let's read the question. He says, prove that the feet of the perpendiculars dropped from the intersection point of the diagonals of a quadrilateral inscribed in a circle on its side are the vertices of a quadrilateral in which a circle can be inscribed. He said way too much. Now he says feet of the perpendiculars dropped from the intersection point of the diagonals of the quadrilateral inscribed in a circle. So first of all, let me have my circle. Right? Then let me have my quadrilateral. Cool. This is A, B, C, D. Now, intersection of the diagonal. That means this point O. Now, he says you need to draw perpendiculars on the sides. So, draw perpendicular from O on AB. Suppose this is the one, right? And from here, this is the one. And from here, this is the one. And from here, this is the one. So, name these points P, Q, R, S. Right? Now he says, prove that the feet of the perpendicular as in P, Q, R, S are the vertices of a quadrilateral in which a circle can be inscribed. So let me make my quadrilateral P, Q, R, S. I need to prove that in this quadrilateral P, Q, R, S, I can inscribe a circle. Now, in a quadrilateral, when can I inscribe a circle? Okay, in a triangle, I can always inscribe a circle, right? In fact, I know in a triangle, the center of the circle is actually the point of intersection of the angle bisectors. Achha. That means in a triangle, I have a circle which is inscribed in it, and its center is the point of intersection of the angle bisectors. Let's see whether that happens in quadrilateral or not. So, if I have to have a circle, right, that means this is the tangent, that means this would be the what? Angle bisector of this angle. This would be the angle bisector. This would be the angle bisector. This would be the angle bisector. That means in a quadrilateral, if all the four angle bisectors are intersecting in a single point, the four angle bisectors intersecting in a single point, that means I can have a circle. So if I need to prove the quadrilateral can have a circle inscribed in it, I need to prove that the angle bisectors should intersect in a point. Intersect in a point. I need to prove this. Right? Let me look at my figure now. So my quadrilateral is PQRS. Now, I need to prove that the angle bisectors intersect in a point. Now, पहले बात इस quadrilateral में एक point तो यही है O. And I know that O is the intersection of this. That means these four segments are intersecting in a single point. If I am able to prove that this is the angle bisector, 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 the four angle bisectors would intersect in a single point. Now, because I can see that is point O. So, all I need to do is prove that this is the angle bisector. Let's start with one first. Right? So, when you read the question, you need to modify your aim. Then, you need to look at the figure, what is happening. Is there a point, there's a particular point where actually four lines are intersecting. मुझे intersection of four lines चाहिए. What is those lines for angle bisectors? Let me check it at least. And it seems like these are angle bisectors. Right? So we have modified our target. Now, I need to see or show or analyze, let's say, show you better, to show that OQ is the angle bisector. Right? That means somehow I need to prove that this angle is equal to this angle. Right? So let me start. This angle को मान लेते हैं. Okay, directly ये इसके equal to होगा ना, right? Just look for those angles which are equal to x. Look for those angles in the diagram which are equal to x. Check करें. अरे क्या using क्या है? Speed of the perpendicular. That means 90 degree. This is 90 degree. This is 90 degree. Okay, this is 90, this is 90. OQBP is a nice kind of quadrilateral. Sum of opposite angles is 180 degrees. That means this quadrilateral is nothing but cyclic quadrilateral. That means there is a circle passing through. Right? 90 degree को use कैसे करोगे? Circle is there, cyclic quadrilateral is there. Right? Now, let's see. OP subtends this angle at the circumference. OP subtends this angle at the circumference. So that means if this is x, this angle will also be x. Let me just darken this up. Right? Okay, fine. What else? अब मुझे तो इस एंगल पे जाना है. तो इस एंगल पे जाना है. अब ये डायरेक्टली ये इसके साथ तो नहीं जाएगा. अब देखिए 90 डिग्री यहाँ पे भी था या 90 डिग्री यहाँ पे भी था. That means I think I can have another cyclic quadrilateral. Can you see that OQCR is also a cyclic quadrilateral? Right? अच्छा, इसका use कर सकता हूँ. Maybe we can. Let's see how. Now, ये वाला angle involve करना. अब ये वाला angle, oh, this chord, right? This chord. ये वाला angle इसके साथ इस एंगल के साथ रिलेटेड होगा, राइट? दिस कॉर्ड सबटेंड दिस एंगल, दिस कॉर्ड सबटेंड दिस एंगल, राइट? बिकॉज ये डायरेक्टली इसके एक्स को प्रूव नहीं हो रहा, मैंने कहीं और ले लिया, कौन सा वाला होने वाला है, राइट? सो दीज टू एंगल्स आर इक्वल. So somehow if I am able to relate this angle and this angle, my problem is solved. I think these two angles are related. Clearly visible. चेक करें. अच्छा, ये वाला एंगल डायगोनल से आया था ना, डायगोनल. So consider the bigger circle. This is the chord of the circle. The chord is subtending this angle at the circumference. Right? Now the same chord is subtending this angle at the circumference. Now this is x, this will be x. You can go to the bigger circle as well. Right? I think the problem is done now. Now come back to the circle. This chord subtends angle x. This chord subtends this angle. If this is x, this has to be x. Now you have proven. Now come back to it. That OQ bisects this entire angle. That means OQ is the bisector. Right? Now, if you are able to prove that OQ is the bisector, on similar lines you can say that OP is the bisector. Right? Then OS is the bisector and OR is the bisector. Or maybe we should actually say angle bisector. Right? Since in this quadrilateral PQRS, this is angle bisector, this is angle bisector, this is angle bisector, this is an angle bisector, and all of these are meeting in a single point. That means there would be a circle inside this quadrilateral. Alright, now to the second part of the question. Now he says if the diagonals of the inscribed quadrilateral. Now we know that there was a circle. Let me draw it again. Right? And my quadrilateral was something like this. Right? Now he says the diagonals are mutually perpendicular. So let me make my diagonal. Quadrilateral ABCD. My diagonal AC and BD. I know they are mutually perpendicular, so this angle is 90. And so is this, and so is this, and so is this. Cool. Then prove that the midpoints of the two opposite sides. Midpoints of two opposites. So let me take AD and BC to be my opposite sides. So midpoint. Suppose it is here. So that is P. And let that be Q. Now mark it on your diagram. This is equal to this. And this is equal to this. Right? Also, this was O. So I will say O. Right? Now, midpoints of the two opposite sides done. The point of intersection of the diagonals, which is O, and the center of the given circle. Now, center of this given circle, so maybe it is here. And for abuse, but it's okay. So here is my point F, which is the center of the circle. Which doesn't look like it, but it's okay. Fine. Right. Now, I need to prove that this point, this point, this point, this point, they form vertices of a parallelogram. Right? So if I join it, the quadrilateral that I actually get, that is actually a parallelogram. This I need to do. Right? Or if I need to prove that the quadrilateral is a parallelogram, I need to prove. Now there are different ways. The easiest way is I need to prove that this side is parallel to this one and this side is parallel to this one. Done? Okay. Now what else do I know? Now this is the center of the circle and I know that Q is the center of the chord. This chord BC is the chord. Center same and midpoint of the chord is joined here. Can you tell me this angle? Definitely this point will, no, definitely this angle will be 90 degrees. Right? I should not be explaining you this, that's given. Inferred. Right? Now this angle is 90 degrees. What else can I use? Now I need to prove that this is parallel to this. Right? यहाँ पे मुझे एक nice angle मिल गया. So what I can do is if I need to prove that this is parallel to this, इसको extend कर देते हैं. Right? Done. Now, if I am able to prove that this angle is also 90 degrees, then can I say that these two lines will be parallel? Right? So my aim is to prove that this angle, let me name this point to be G, OGQ. To prove angle OGQ is 90 degrees. Right? ये वाला एंगल अभी मुझे 90 डिग्री प्रूव करना है, मुझे स्टार्ट तो करना पड़ेगा. ऑल्सो मैंने अभी तक 90 डिग्रीज का यूज नहीं किया, म्यूचुअल परपेंडिकुलर डायगोनल्स का. राइट? ये भी 90 है, ये भी 90 है. ओह अच्छा, आई नीड टू प्रूव 90 ओवर हियर और यहाँ पे 90 मिल रहा है. ओके, अब डायरेक्टली ये तो उसके कोई प्रूव नहीं होगा. मैं क्या करती हूँ, इस एंगल का कोई पार्ट ले लेती हूँ. कौन सा पार्ट ले? अब यहाँ पे 90 डिग्री है, ये लाइन ऐसे बनी है. सो व्हाट आई डू इज आई विल टेक दिस एंगल, लेट मी कॉल इट एक्स. राइट? एंगल स्टार्ट करना है. राइट? मुझे 90 डिग्री लेके आना है, मुझे कहीं से स्टार्ट तो करना पड़ेगा. सो आई हैव टेकन दिस एंगल टू बी एक्स. दिस वन. Right? Okay. Now, this entire angle was 90 degree. If this is x, that means this angle is 90 minus x. Right? मुझे अब ये 90 डिग्री प्रूव करना था, ये 90 minus x हो चुका है. That means somehow ये मुझे x के इक्वल प्रूव करना होगा. Okay. Now, ये angle x के इक्वल प्रूव करना होगा. Let's see. What else? क्या है? अब और देखें, अब यहाँ पे एंगल मुझे x मिल रहा है. अब मैंने इस मिड पॉइंट का यूज नहीं किया अभी तक. Right? Mind it, if this is x, this will be x. Vertically opposite angle. Right? अब what else? इस पॉइंट का यूज करना है. ये मिड पॉइंट है. एक मिनट. मिड पॉइंट है and DOA is what? Is a right triangle. Right? Triangle DOA is right angle. Right angle triangle, and that means this is the hypotenuse, and this is the midpoint of the hypotenuse. Now, is there a relation? Is there a theorem or a result we know that happens in right angle and the midpoint of the hypotenuse? I know that midpoint of the hypotenuse is equidistant from all the three vertices. As in, this is equal to this is equal to this. Nice, nice. Wait a second. Now that means POA, triangle POA is isosceles. Right? Now if POA is isosceles, this angle is x. Obviously this angle is how much? X. Okay. तो मुझे तो वहाँ पे जाना है. Can I relate these two angles? I think I can. Come on. This angle, we can concept and करें. This chord CD. Chord CD is subtending this angle x at the circumference. Chord CD is also subtending this angle at the circumference as in P. Right? Now this is x, this is x. Done. This angle is 90 minus x. This is x. So that means in this triangle, this angle has to be 90 degrees. Right? Obviously, this is 90, this is 90. That means OG is parallel to SQ. अब OG का extension ही था. So that means this is parallel to this. Right? I have proven that OP is parallel to SQ. Right? On the same lines, using the same not constructions, using the same logic, you can prove that PF is parallel to OQ. Now, since both pairs of the quadrilateral are parallel to one another, that means this quadrilateral has to be a parallelogram. Hence, let's move on to the next question. Now he says find all positive integers n such that 1 1 1 1 1 space n is a perfect square. Right? I need to find all positive integers. Okay, so let's just start finding out some at least. Let me try to understand how will I figure out whether this number is a perfect square in a certain base or not. Right? So let me take my base to be 2 first of all. Right? That means this number, if I convert it into the base 2, that will be 1 into 2 raised to the 4 plus 1 into 2 cube plus 1 into 2 square plus 1 into 2 plus 1. I have converted my base into a decimal system. Why? Because I know how to work in that. Or I can say I have written this number in the expanded form. Right? So this number turns out to be 31. Now you can see that 31 is definitely not a perfect square in the decimal number system that we are acquainted with. Right? But the question is, do you think if the number is not a perfect square in the decimal number system, it can be a perfect square in the binary system? Let's just figure it out. Let's just analyze it. Whatever the number may be, right? And base is equals to, right? And I convert it into decimal system, right? And in the decimal system, it is a perfect square. That means if it is a perfect square, it would be what? Product of two numbers, in fact, the same numbers. That means if this is A, this is A. Right? Now, if I convert it back, A को मैं अगर वापस change करूँगी, वो suppose B में change होता, अब A को वापस change करूँगी, वो B में change होगा. Right? I have written this number as a product of same numbers. That means if the number is a perfect square in decimal number system, it should be a perfect square in what? The other number. And अगर वो यहाँ पे perfect square में नहीं है, जो मैं से ऐसे नहीं लिख सकते, right? As product of same numbers, यहाँ पे कैसे लिखूँगी? That means if 31 is not a perfect square in decimal, that means this number in the base 2 is not a perfect square. Done? Okay. Let me check for the base 3 now. N is equal to 3. So this is 1, 1, 1, 1, 1. In the base 3, that will be 1 into 3 to the power 4 plus 1 into 3 cube plus 1 into 3 square plus 1 into 3 plus 1. And this actually comes out to be 121, which is a perfect square. Now, since it is a perfect square here, that means this is a perfect square. You found one value of n for which this quantity is a perfect square. Right? At least ये तो तुमने निकाल लिया, right? Because you will get some credit for this. At least you found one number. Right? Then you will try for n is equal to 4. Right? That will be 1 into 4 is 4 plus 1 into 4 cube plus 1 into 4 square plus 1 into 4 plus 1. Which will turn out to be not a perfect square. Right? Then maybe you are trying for the question because you will have full 15 minutes. You will check for 5, 6 and so on. And you will find that none of those numbers are actually giving you perfect square. Now the question is, should we just say that n is equal to 3 is the answer? No. That's not. Because you need to look, what if the perfect square that you will find that will come for a 9,989 when the base is that, right? So we need to see what is happening in further numbers. Or what you can do is you can try the infinite cases, and if in each case you can say they do not, there is no perfect square, then the solution is complete. But obviously for that you need infinite time, which is a very problematic thing in itself. Right? So that means by hit and trial, you found out one answer which is appropriate, you will get credit for it, but your solution is incomplete. So we need to proceed further. Right? Okay. Now, instead of taking individual values of n, like 2, 3, 4, let me just consider it as n and convert this number into the decimal number system. So, it would be 1 into n raised to the power 4 plus 1 into n cube. So, I am writing out, it will turn out to be n raised to the power 4 plus n cube plus n square plus n plus 1. Right? This is my polynomial actually. I need to see for what values of n, this polynomial will become a perfect square. Now, obviously, in general, it is not a perfect square. The polynomial is not a perfect square, right? Because n is equal to 2 के लिए तो था नहीं. वैसे भी देख रहा है, perfect square वाला polynomial नहीं है. Now, but मुझे तो perfect square चाहिए for the value of n. अब ये perfect square नहीं है. ठीक है. Now how should we proceed with the problem? Now obviously we cannot check for n is equal to 4, 5, 6 so on because there are infinite number of natural numbers, right? So if I need to talk about all the natural numbers at one go, it is not possible to talk about them individually. So let me partition my number system, or let me more appropriately I should say let me partition my set or selection of natural numbers. A basic partitioning that we are very well acquainted with is the partitioning on the basis of divisibility by 2. Why? Because first partitioning that we see whether the number is even or whether the number is odd. Or we can say whether the number is of the form 2k or 2k plus 1. Right? Now you might be say they might be partitioning like divisibility by 3. So 3k plus 1, 3k plus 1. Another partitioning might be 4k plus 1, 4k plus 2, 4k plus 3. I don't know which partitioning would be appropriate here, but I need to start from somewhere, right? So let me start with this one, the smallest, when I just need to make 2 subsets, right? So I will talk about n when it is even, n when it is odd, right? So let me consider when n is even. Now when n is even, that means n is of the form 2k. Let me study what happens to this polynomial when I substitute n as 2k. So it will turn out to be 16k raised to 4 plus 8k cube plus 4k square plus 2k plus 1. Right? I need to study what happens to the polynomial. Right? For what values of k does it become a perfect square? Right? अब ये perfect square खुद नहीं है, but कैसे करें आप? ये खुद perfect square नहीं है, but मुझे perfect square बनाना है. So let me try to find some polynomial which is near to this one and which is a perfect square. If I need to look for perfect square, ये directly ऐसे तो नहीं दिख रहा. ऐसा polynomial ढूंढते हैं जो perfect square के पास हो. Right? अब ये polynomial जो कौन से perfect square के पास होगा? Let's see. अब ये polynomial ये आ रहा है, ये आ रहा है. अब polynomial के पास चाहिए तो at least जो first 2 terms से same रखती हूँ. So think about a polynomial in which this term occurs and this term occurs. अब ये 16k raised to 4 तो खुद perfect square है, so that means 4k square डाल देते हैं. Plus अब ये 8k cube है, perfect square नहीं है, that means ये 2ab वाली term से मिलने वाला, right? So मैं यहाँ पे 8 चाहिए ना, तो यहाँ पे डाल देती हूँ k. Because when I square this quantity, I get 16k raised to 4 plus 8k cube. Same बनेगी, right? So let me write the square. So 16k raised to 4 plus 8k cube plus k square. Right? Okay. When I square this quantity, I am getting this polynomial. Now compare this polynomial and this one. 16, ये तो obviously हमने जानबूझ के सेम किया था. This 4k square. अच्छा, ये लेस नंबर है, ये obviously पॉजिटिव है, right? उसमें फिर से पॉजिटिव नंबर ऐड किया, पॉजिटिव नंबर ऐड किया. That means definitely this polynomial is greater than this one for positive values of k. Right? Okay. Fine. अब ये पास में पहुंच गया. Like let's go nearer even, right? ने पास तो बनाया. Now let me see whether I can go nearer now. Now इससे next वाला थोड़ा सा बड़ा करना है polynomial को, right? यहाँ पे k है. Next वाला देखते हैं consecutive में, because k तो integer है, right? k integer है तो मैं यहाँ पे 1 डाल देता हूँ. 4k square plus k plus 1. Because this is the lesser one, right? So that means मैं उसके पास जाऊँगी तो मैं अपने थोड़ी सी quantity बढ़ा देती हूँ. तो मैंने plus 1 कर दिया, right? यहाँ पे इसको चेक करें. So 16k raised to 4 plus k square plus 1 plus 8k cube plus 2k plus k 8k square. So if I write it properly, मेरे पास आएगा 16 plus यहाँ पे 9 कर देते हैं. 9. Okay, so let me write it और यहाँ पे plus 1 कर देते हैं so that do not forget. So 8k cube plus 9k square plus 2k plus 1 plus 2k plus 1. Okay, अब check करें whether I have become nearer to this one or not, right? This is same obviously, this is same obviously. Okay, 4k square यहाँ पे 9k square. Okay, 2k plus 1 same, 2k plus 1. Now compare this polynomial and this polynomial. This quantity is this quantity, this quantity is this quantity, same. अब यहाँ पे 4k square है, 9k square है. Now definitely 9k square is greater than 4k square. That means this polynomial for a a given integral value of k, the value of this polynomial is greater than this one. That is weird. यहाँ पे अब आया क्या? This was a smaller one and this is a greater one. That means this polynomial lies between this and this. चेक करें, इसको लिख लेते हैं हम. तो यहाँ पे and ये quantity यहाँ पे. The polynomial lies between this and this. That means the polynomial lies between this square and this square. हाँ, मेरा polynomial lies between this square and this square. अब मुझे दिख रहा है, this is an integer, this is an integer. In fact, these are consecutive integers. My polynomial lies between squares of two consecutive integers. अच्छा, lies between squares of two consecutive integers. That means ये खुद तो square हो नहीं सकता. This cannot be a square of an integer. Consecutive के बीच में lie कर रहा है, उनके squares के बीच में lie कर रहा है. खुद square of an integer कैसे होगा? Because I know that integer में consecutiveness होती है, right? So that means this polynomial, no matter what the value of k is, it cannot be a perfect square of the integral value of k. Because I have shown that this polynomial lies between square of two integral values. So this cannot be a perfect square. Now this cannot be a perfect square. That means this cannot be a perfect square. Case क्या था? हाँ. Then n is even. I have shown that this polynomial, as in this one, this cannot be a perfect square. Right? So n मैंने half किलो खत्म ही कर दिया. n जब even है, so it's definitely no matter what you do, this number cannot be a perfect square. Now, अब second half के लिए देखते हैं. When n is an odd number, that means when n is equal to 2k plus 1. Yeah, I might need space for that. So let me consider the second one. Right. Now, the second case is when n is odd. When n is odd, that means n is of the form 2k plus 1. Right? So let me just substitute it. So I will get 2k plus 1 whole raised to power 4 plus 2k plus 1 whole cube plus 2k plus 1 square plus 2k plus 1 plus 1. Right? You can open this up. Square का square करना तुम्हें करना आता है और binomial you can use it whatever way you like. I will write directly what will come out to be 16k raised to power 4 plus 40k cube plus 40k square plus 20k plus 5. Right? This is my polynomial. Now I know this polynomial as such is not a square of some polynomial, but I want it to be square for some value of k. So let me make my polynomial near to some square of a polynomial. कौन से polynomial के पास जाए हम? पहले तो ये और ये बनाते हैं. Simple, right? That means 4k square चाहिए होगा मुझे. And यहाँ पे मुझे 40 बनाना है. So that means मुझे 2ab से 20 मिलना चाहिए. So 4 into यहाँ पे 5. Done? Okay. Square खोलें. तो ये हो गया 16k raised to power 4 plus obviously 40k cube because I made sure of that plus 25k square. Now as you can see, definitely this polynomial, the value of this polynomial will be greater than the value of this polynomial. You can see that. अब उसमें हमने next वाले पे check किया था because I wanted to go to nearer one, so plus 1 पे check करता है. So 4k square plus 5k plus 1 whole square. Right? इसको obviously a square plus b square से हम open up कर लेंगे. मैं directly लिख देती हूँ. What happens? This turns out to be 16k raised to power 4 plus 40k cube plus 33k square plus 10 plus k plus 10k plus 1. Sorry. Right? Now compare this polynomial and the other one. So ये तो same है, वो तो हमने होना था. अब यहाँ पे 40k square, okay, तो greater आ गया. यहाँ पे 20, वहाँ पे 10, यहाँ पे 5. Definitely the value of this polynomial is greater than the value of this one. That means ये इससे भी बड़ा है, ये वाला इससे भी बड़ा है. चलो और जाए. Let's go to nearer. अब तुम पहले गए थे यहाँ पे, तुमने एक ऐड किया वन, तुम nearer पहुँच गए. Let's see अब और ऐड करोगे whether you approach something to nearer or not. So let's go for इससे next वाले पे. 4k square plus 5k plus 2 whole square. Right? Now, this square you can open it up and it will turn out to be 16k raised to 4 plus 40k cube plus 41k square plus 20k plus 4. Right? Okay. Check it out. Compare this polynomial and this one. Obviously, first two terms the same है. अब यहाँ पे 40k square है, यहाँ पे 41k square है. Great हो गया. 20k same है. यहाँ पे 5 है, यहाँ पे 4 है. अब यहाँ पे k square extra है, वहाँ पे 1 extra है. अब k square और 1 में से bigger कौन सा होगा? राइट एक बार बताओ हम 2k plus 1 वाला केस कंसिडर कर रहे हैं राइट अगर k greater than 1 है दैट मीन्स आई एम टॉकिंग अबाउट n equal to 5 7 9 and so on अब तुम बोलोगे 3 का क्या हुआ you already checked for n is equal to 3 which turned out to be a perfect square लिखा भी हुआ right so that means when I'm moving further k square is definitely greater than 1 now अब k square greater than 1 है तो यहाँ पे जो 1 का इशू हो रहा था this quantity is definitely greater right now this polynomial is greater and this polynomial is lesser so that means my polynomial lies between this square and this square again I have proven that my polynomial lies between square of this and square of this basically between squares of two consecutive integers if an integer lies between square of two consecutive integers, that means it cannot be a perfect square. Right? Again, I have proven that this polynomial, when, as considering this case, when n is odd, the polynomial will not be a perfect square. Right? मैंने even के लिए कर दिया, odd के लिए कर दिया. Have I proven for all natural numbers? Yes. Because either the natural number is odd, which I have proven, or it is even, which I have proven. Right? और वाले में एक केस था जो मैंने separately लिया हुआ था, so that is it. I have covered all natural numbers. Rather than taking step by step chemistry 4, 5, 6, I have partitioned my natural numbers into two cases and dealt with it. But the problem is, what if it was not dealt when we partitioned into two sets? You could have moved on to partitioning into three sets. 3k, 3k plus 1, 3k plus 2. You could have partitioned into 4 subsets. Or maybe 10 or 11, it depends on the question, right? So you should know how to divide or partition your problem into smaller cases, which you can deal with, right? अगर ये इसमें से नहीं भी हुआ था, you should have at least found out that n is equal to 3 पे, ये तो because some credit you still get. You might not be able to do the entire question in the paper, but you should be able to do some part of it because then also you are getting some credit, right? So with this, we'll end the discussion. All the best for your coming exam. Just remember one thing, you have an incredible opportunity to do the paper that will be set by the best teachers of the entire country. You have the opportunity for that. Because usually, in more level, obviously you need to pass through all those levels and then you get to give in more. But now you can. Right? You have the opportunity to actually study from the best professors to utilize it. When you have time in the paper, don't be idle in it. You have sufficient time. Exhaust each and every case. Whatever you know, just try to apply. Those limited concepts are there. It's just you need to see what can be applied over here. Whether polynomial question is there, whether number theory question is there, whether geometry question is there. You have the knowledge. Just apply it. You have sufficient time. Be patient. Do not be disappointed. Alright, and also, very, very important thing, you should be able to enjoy the paper. Alright, so all the best. I will see you next time.